All right, hello ladies and gentlemen. So back to Algebra 2, and we are solving systems now using a matrix and reduced row echelon form. RREF is how I'll pronounce it in class, so I want you to know that there's two R's there versus the row echelon form that we were using last unit. What I want you to notice here is that in these three equations, we have P, M, G. And they follow that order on each equation. As we write a matrix equation, the order of the letters is important, and that's what this column is here. The matrix to the left, that big box, is all of their coefficients, and the signs are included in that. So here, on this row, we have 3, we have 4, and positive 5. And then, how do we use this value? That's my matrix on the far right of the equal sign. So 2440 goes in that box, or matrix, to be mathematically correct. And so we can do the same thing here. So we take the coefficient of P, which is 6, the coefficient of M, which is positive 5, and the coefficient of G, which is positive 2. And so our last row. And remember, if you don't see a coefficient, it can be helpful to write that one coefficient. So this bottom row is 3, 2, 1. What are we missing on the far right? What this equation equaled? The 30.40. And the bottom one, 13.4. So in linear algebra, a study of mathematics, that's when you need the matrix equation. I want you to have seen it once before you get there. What's the purpose of what we do now is we create an augmented matrix. An augmented matrix is combining two matrices together, appending them together. And so this top row looks like this. There's a dashed line separating them, and on this side. So the augmented matrix is a matrix that holds the constants and coefficients, no variables. But that's why it was important for those variables, those letters, to be in the same order in each equation. So we can fill this out here. Okay, so a few things that we do need to talk about are, one, how do we put this in the calculator? And I'm going to show you two ways. And the second is talking about rows and columns. So what I need you to know here is that here we have 3 rows, and here we have 4 columns. So rows are these horizontal rows of numbers, and our columns are the vertical rows of numbers. Okay, so one way to do it is we can type RREF, which is the calculator's method for solving the matrices, and kind of what we started to show you with the Gaussian elimination method. So here's the first way I can do it. I can go RREF, so I go and I type it on a calculator page. So down here, we have RREF. Notice how it went from italicized and the font changed. So that's telling me it recognizes this method, so parentheses. Now I can do the sideways face. And there's my matrix. And when I select this, it's going to ask me for rows and columns. So 3 rows, tab. I want to make that, I want to make that 4 columns. And then I want to hit enter. So now notice there's a spot for each one of those values that we had before. And so now we can go and record those. 3, 6, 3. Oh, sorry, let's go sideways. So 3, 4, 5, and 24, 40. And so this is why sideways works a little bit better. So I start with 3, I press tab, and it moves me to the next cell. 4, tab, 5. Let's make sure those numbers are correct. And on the other side, 24, 40. So I'm going to go tab again. And what's nice is it moves me over here to the cell where the cursor is blinking. And now I can keep typing the next numbers. 6, 5, 2, and 30, 40. So 6, tab, 5, tab, 2, tab, and 30, 40. Now notice that I'm going to go back and I'm checking my numbers as I go and making sure that I do have the correct numbers. That's one of the easiest ways to mess up. Tab, let's go do the last row. 3, 2, 1, and 13, 40. So 3, tab, 2, tab, 1, tab, one more time, 13, 40. Now, this is really important over here. So it's actually solving the system for us, and I'll start to break it down how this connects. Okay. So 1.75. 3.6 and 0.95. Okay, so how does this relate to what we started with? So now we can actually write an equation. So remember, this was the P column. That was the M column. And that was the G column. Okay, so now what we can observe here is, let's write an equation. So now we're going back to an equation. So I can say 1p plus 0m. So 1p plus 0m plus 0g equals, let me move this over just a little bit, 1.75. Okay, so what does this really mean in terms of what we're doing? Well, we have 0 m's, so 0 times m is 0. We have 0 g's, 0 times g is 0. So we have 1p. Well, 1p is the same as just p. So this first line is telling us our solution for p. And if you notice, I messed up here, so we got to change those letters. P equals 1.75. Well, this matrix is called an identity matrix. And each row is giving us a piece of information. So the next rows will talk to us about M and G. So pulling from the same idea for this one, we could say that we have 0p plus 1m plus 0g, and it equals 3.6. And so we go back to that notion of, what is this telling us? And the better I can understand this, I don't have to write this down every time. I'll know my answers. So here we have 0p, we have 0g, and so we have 1m equals 3.6. And so m equals, and so the last one, so this last row, I have 0 p's, I have 0 m's, but I have 1 g. So they're telling me that g is 0.95. Now, many times we can also write this as an order triple. We're going to maintain the same order that we had within the problem, with the exception of its x, y, z. We need it in that order for when we talk about three-dimensional graphing. But it is possible to actually change the order, and if you'd like to kind of know about that, we can talk about it in class. Okay, so let's take a look at a second example, which is going to require a little bit more work. Our matrix was ready to go. Oh, so the only other thing I didn't tell you before we move on is what's the second way that you can do this if you don't want to type it in and you want to remember menu steps. So you go menu, 7-1, or sorry, 7-5, and this chooses the RREF part. And then now you go menu, 7-1-1, and that's what creates your matrix. When I do my next problem, I'll do the menu steps. You can pick and choose which way feels better for you. Okay, so it says box any equation that is in standard form. AX plus BY equals C, plus CZ equals D. That's kind of a little confusing, but what it's saying is that it wants all my variables on the left-hand side equals and the constant on the other side. Take a look at this equation. Okay, so for the matrix equation, we're gonna get rid of that part. I will make you set that part up, only because I want you guys to focus on the matrix. At the end of the video, I'll come and I'll fill that in if you want to see it. Okay, so why is that part important? Well, so this row down here would be 1, 2, -2. Why is it -2? Because it's a subtract 2z there. And -4, because it's a -4. Okay, let's start with the easy equation. The easy equation is when all the letters are on the same side. But there's a problem with this bottom one. So what we can say here is they're not in order. So we want to put them in order. So I'm going to circle the z. We're going to circle the 3x and the sign that's in front of it. Let me clean that up a little bit. And the y with a sign as well. And so now we can put these in order. So here we can say we want the x term to go first. Then we want the y to go second. It's a positive z, and we want z to go third. And it equals 9 on the other side. So what we get here is, and it may be helpful to come and write that one coefficient, 3, -1, +1, and 9. Okay, so that one just took some rearrangement, but when rearranging, the sign to the left of it is attached to that number and variable. It moves with it, and that's our commutative property. So the last one to talk about here that's a problem. I need to get those variables to the other side. So we're going to copy down this equation. So y equals 3 minus 2x minus z. And we want to move these terms to the other side. But it's not as simple as just moving the minus 2x over. We have to use mathematical properties. So what do? We break it down from the equal sign. In order to go to the other side of the equal sign, I have to do the opposite of minus 2x. So we're going to add 2x. Now what we do to one side, we want to come and do to the other. So over here, we're going to add 2x. Okay. But we also have a minus z. So we want to do the opposite there. And so we're going to add z. And I can stack this below it if I don't have space. Okay, so what happened here? So on the left-hand side, we want to put them in order. So I want the 2x to go first. It's a positive y, so plus y. plus z. And now we get to the other side. What does it equal? So over here, we did that on purpose. And the x terms cancel out. And the z terms cancel out. And what we're left with is that constant on the other side. Yet again, those one coefficients may be important there to help remind us that this row is 2, 1, 1, and 3. Yet again, we have 3 rows, and we have 4 columns. So this helps. Our rows are this way, and our columns are that way. Okay, so let's go find the solution to this equation. So using the menu steps I talked about earlier, menu, 7 for matrix, and 5 for reduced row echelon 4. Okay, now it's going to put me inside there, and what I want to do is now menu, 7, 1, and 1. So we're going to create a matrix inside there. We have to specify the number of rows, tab. You'll find out if you don't use tab there, it gets a little tough, where you got to use the cursor. 4. Enter. And now I can input my values. So now we can go set that up. 2, 1, 1, 3. And remember, tab is how I'm moving between the table. Tab. Okay, so 1, 2, -2, I forgot the other number, and -4. Okay. 3, -1, -1, and 9. Now before I hit enter, I definitely want to check my numbers and my work. And now I can hit enter. For a lot of what we're giving you in class, at the regular level, I want to make sure that you have nice whole numbers. So if you're getting weird fractions, it's like, okay, I messed up somewhere, unless it's one of those special cases, which is in the next videos. So at this point, there's our solutions right there, those 3 values. Okay, so 2, -2, and 1. Let's go record that. So 2, -2, and 1. So in this order, I'll do it one more time for us, just in case you kind of had some trouble seeing it. This is my x column. So this is going to tell me that x equals 2. This one tells me y equals -2. And the bottom row tells me z equals 1. Keep in mind that how else can I write this? I can put here x, y, z. But let's say that you still had a little trouble seeing that. So this top row would be 1x plus 0y plus 0z and equals 2. This row is 0x plus 1y plus 0z equals -2. And one more time, this last row tells us 0x plus 0y plus 1z, 1z, equals 1. And now we go back to what is it telling us? So there's no y's, there's no z's here, so x equals 2. There's no x's, there's no z's, there's just a 1y, so y is -2. And there's no x's and there's no y's on this one, so z equals 1. All right, so this concludes our notes there. For those that want to see the matrix equation, I'll slide up so you can take a look at that. So here, the matrix equation, after we set everything up from down below, would pretty much be those same numbers there. So we wanted the order of x, y, z. So these were the constants that were going to be left on the right side. And then after we got each equation in order and the variables on the left-hand side, so just for those who wanted to see the matrix equation, and remember we had to reorder this one,